I am working here as project assistant under NAHEDCA's project eNAM Agricultural University, eNAM. I welcome you all to the second day of lecture series on agricultural market intelligence and eNAM. I would like to invite Dr. Kumar sir, who is the former professor and head of the department Agricultural Economics, IERI, New Delhi, for today's technical section, which will be last. And the topic will be demand and supply analysis.
So in morning, we are just estimation of demand model. So okay, we have covered this part, that how to arrange the data. Then later on, we already shown that in the first stage, we estimated this model with putting the constraints of homogeneous of the zero income prices. Then the second stage, after doing this, we were having second stage that the expenditure on cereals is a function of that. Most important part is its model. After doing this, we profit analysis, IMR will work out. This is the model. We have these. On the right hand side, here they are my dependent variables. If you estimate, we estimate all the 6 equations together, and then second equation 1, we have the first dependent variable and the rest of the expanded variable. Then we have the equation number 2, equation number 3, equation number 4, and last equation is the edible oil, and so. So once we write this is under the framework of derivative. You can write this statement under state out, which I show you with some right side of that. We have all 6 equations now. Last one is the share of expenditure on edible oil. So what we do, we impose the homogeneity conditions. The coefficient of the B2, B3, B4, B5, B8 equal to 0. From second equation, we are saying 14, 15, 16 is at 0. From third equation, fourth equation, fifth equation, and sixth equation. Then we have the symmetric conditions that B3 equal to B14, B4, 26, and 4. If you write in a matrix form, you can always find out. In the limit, we give the coefficient from 1 to n, and therefore this is there. But if you go straight up, then you not face that difficult. Now go up. Yeah, I think once you have, you can just read yourself and see whether this is the idea is just to fix the constraints for estimating the demand model under AIDS on the third stage. And then we say that this is the model. So there are 7 groups, 1 we are editing, and 6 we are estimating, and then we are imposing this restriction, symmetry restriction, and homogeneity. Once we do it, we estimate the model, and then we derive the elasticities by using the formula RP. We can go to supply. Next. So, next. Yeah. So let's talk about the supply analysis. In the supply analysis, this is the profit function approach is quite widely being used. Profit function approach is quite widely being used. So, what is the profit? We have the gross receipt minus cost. So it becomes the function of prices, inputs, wages, and fixed factors. So once you fit the profit function, then you can work out the factor demand equation and output supply equation. How you work out? We write out this equation in any form, modular, generalized, quadratic, transpose. Any form, we can write the profit function. Once we write the profit function estimated, we differentiate the profit with respect to output price. That give us the supply of that commodity. If we differentiate with respect to input with minus sign, it is the demand for inputs. So that way we derive the supply equation and the input demand equation. So I think those are reading the Untitled book also. It has been explained how to derive the factor demand and how to supply elasticity by using the profit function approach. This is one way of doing it. You can apply a revenue approach. What is revenue? That you have the gross revenue. Let's say there are 6 crops, 6 commodities. You can have the gross revenue is a function of the price of all the 6 commodities. If we differentiate the revenue with respect to first commodity price, it will be the supply of the first commodity. If we differentiate the second commodity price, it will be the supply of second commodity, and so. And that way we can derive the supply of all the commodities. But in the revenue equation, we cannot derive the factor demand equation. We derive only the supply equation because the total revenue is equal to sum of all the commodities values. And we fit the model that revenue is a function of prices, and then we differentiate, and we if we differentiate with respect to output price, we get the supply equation. So by revenue model also we can work out the profit function approach, and transcendental logarithm model is quite good as compared to formulas if we apply the profit function. Now, this is the input demand equation. Once we differentiate with respect to inputs, price with minus sign, we get the factor demand equation. Now, this is the model which I say that you can apply twice of techniques: factor demand, yield, and supply. This is the model one can apply and use it. Once you apply, you can measure the impact of wages. The wages will affect the machine labor, and machine labor affect the fertilizer, and fertilizer will affect the yield. The second component, wages will affect the machine labor, and machine labor will affect the yield. First line, wages will affect the human labor, and human labor affect the yield. So if you sum up the three processes, we get the effect of wages on it. That way we compute this elasticity. Similarly, because if you have that six equation model and through differential calculus, you are able to drive this one. And bottom. Similarly, okay. It is a graphic presentation, as I did yesterday, of the first one. First is a mathematical presentation, and same thing you can write graphically to explain the process. That's how you, once you estimate how wages affect human labor affect machine labor affect the fertilizer, and machine labor fertilizer affect the wage. That's why this bullock same way bullock labor affect the machine labor, and machine labor will affect the yield. Second process, machine labor will affect the fertilizer will affect the yield. Then we get the bullock labor affect the machine labor. So they are bullock labor affect machine labor. This way, they are making the graphic presentation of their process. Similarly, if you look at the machine labor effect, you can look irrigation help increasing the production in many ways. First of all, if we start reading from end to first, reverse way. That irrigation area affects the crop area. Crop area affects the fertilizer, and fertilizer affects the yield. This is the one process. Then crop area also influences the machine labor, and machine labor affects the machine labor affects the yield, and that is the machine effect. It means you are getting how much yield increase through fertilizer from irrigation, how much affected by machine labor, how much affected by hiding varieties, how much affected by direct effect, hiding variety, and so on. So you sum up all, that will be total effect of irrigation on yield. So irrigation will affect through fertilizer, through machine labor, through crop irrigated area, through fertilizer, through and so. So that process goes. And if you present it graphically, this is the graphic presentation of that combination of mathematics. Then same way literacy affect the adoption of hiding variety. But hiding variety affect the fertilizer, and fertilizer affect the yield. Second way, if literacy affect the hiding variety affect the mechanization affect the fertilizer use, and fertilizer use affect the yield. Literacy also affect the adoption of hiding variety, and hiding variety influence the machine labor, and machine labor affect the yield. First one, literacy affect the hiding variety, and hiding variety affect the human labor, and human labor affects the yield. And that way, and the total effect is it. So if you read by this way, then only we can know what is the process, how the literacy is going to influence the yield. So literacy does not affect directly yield. It affects through adoption of technology. It affects adoption of higher use of modern inputs, and machine labor, fertilizer, and reduction of inferior inputs. And then all the inputs influence the yield. Similarly, electrification. So electrification affects the adoption. If electricity is there, more people like to adopt the hiding variety. The more peptide likelihood of the hydrolytic fertilizer consumption increase. If this is one process, and through fertilizer we increase the. So it is you can decompose the total impact of electricity on yield. That this is the fertilizer component impact of fertilizer. This is the impact of machine. This is the impact of hydrolytic, and this is the impact of human labor. And then you compare all components. Which component is more powerful? That will be the first priority where we have to pay our policy emphasis. That whether we should work on fertilizer subsidy, whether we should work on machine labor subsidy, or whether we should replace the human labor by mechanization with so. And this is the graphic presentation of this village electrification. First influence adoption. Once adoption comes, machine use increase, fertilizer increase, human labor it influences the human labor because of machine labor there is a substitute to human labor machine and then heat. So this way, if you go fertilizer price, it affects the fertilizer. It does not go manually. Increase of fertilizer price directly influences the yield because it does not go through machines everything directly consumption because you pay the money and farmer buy the fertilizer. Similarly, TFP is again a direct shifter or supply, and that is why the coefficient of TFP equal to change in yield as a result of TFP. So this way we compute the impact of all the variables. Wage effect, bullock price, machine labor, fertilizer, organic manure, net sown area, village electrification, rural electricity, and total factor. So these are the elasticities we estimate with respect to all the factors. Once you estimate, and you know what is the growth of all the exponent variables. So you multiply the growth to elasticities and then sum up. That will be the total effect of supply. So question comes, how to make the assumption on the exponent variables. Past data we know, and future data we can assume what we feel best with the help of experts, with the help of your knowledge also. Just like we say, okay, animal labor charges will increase with the same rate, human labor will increase same rate in future by 2020. That this study has been done in 1995. And then machine labor and fertilizer. So if you multiply these two, infrastructure and so we get the growth. Once we get the growth, we can predict the supply. By the same formula, xt is equal to xt0 1 plus r raised power t. So that's why you can get. And then you can compute baseline projections. This is for rice. In the paper, you find rice, wheat, coarse grains, and pulses. Right? This is the paper in the literature. And there, in the appendix, these all formulas are given that how you drive, and the method has been explained how you can drive them. But in the text, you find the explanation of this four. So here, without AFP growth, there are scenarios, baseline scenario, without AFP growth, without acreage and TFP, right? So we can develop number of scenarios and see which looks better. So just like the baseline, our demand 127 million tons, and it ranges 103 to 127. And if you look the active production, they are quite close to this. So even 25 years, the projections is still valid. It means it is sound methodology by which we can have the supply and balance. By 2030, these are the numbers, and this will be also computed by another model they are also matching this. So we can study the effect of acreage. That if acreage increase, then only there is a small surplus of price. We can have the TFP and area growth effect. This is the acreage. And acreage is not there, so only we have TFP effect. If TFP acreage both are zero, then we have only the input. So this way, this is the second method by which we can use this. There is a one paper on this. So third approach, which is most commonly being used, the transload cost function. Working. Okay. And transload here we can use the transload cost function. It is very widely being used at present, and we must and it gives very authentic systematic results on factor demand and output supply. Then we can use baseline assumptions, TFP without TFP, without acreage, without so, or you can have some other assumption. No, this is the transload function. What is transload function? Cost is a function of output and inputs, price of inputs. This is the transload. Right? And for the transload function, we estimated the share equation. We have system constraints on this, homogeneity constraint, monotonous and kept, and the convexity in the input side. This is the model we estimate. Share of inputs. In the transload model, we estimate the share of inputs as a function of input price and other factors. Share of higher input. W is the price of inputs. And T is the number of years. Number of years take care of technology part. And then error time. And then we apply the homogeneity constraints, that sum of gamma ij with minus sign. This is the constraint. Then we apply once we apply and estimate it, we can estimate the elasticity. This one. This is the elasticities, and for last for all, and then for I not equal to j, they are the cross elasticity, and I did effect of fertilizer on labor, effect of fertilizer on irrigation, and so. So this is the one we estimate. Then we estimate the standard error of this elasticity by this formula, and we also have. So you will get from one onwards, you will be able to get template of this, by which we estimate it, we put the coefficient one side, and then how we compute this. You can do by on Excel sheet also, and you can see the survey with the template on it. Then we estimate the elasticity of supply with respect to price. The price elasticity of supply is equal to, no, this is the factor demand elasticity. We estimate the factor demand elasticity, and from the factor demand elasticities, we estimate the supply elasticity. This one by using this formula. If you need once and twice and the papers, then it's very easy. Otherwise, I know how the figure looks like. The gamma is the share. This is the output supply elasticity. This is the factor demand elasticity. Factor demand and so we get some numbers like supply response elasticity for crops. They are highly elastic, but it's still quite big. The supply number is quite big, 0.2. It's not that small. So we have the supply growth is equal to output price effect, input price effect, area effect, and TFP. So we get the share of supply growth. So once you estimate this elasticity and you know the growth of input price, output price, input price, area, acreage, and TFP growth, we can estimate the supply. Once you estimate the supply growth, you can predict the supply here using the baseline supply. This is the baseline assumption S2 S, and then with under different assumptions, we are able to estimate this. So here your supply is C01, C02, and then we have the demand. Then we can compare whether they are matching or they are different. Then supply. Just like here demand is 39, and here under this scenario we are in shortage, in scenario we are in surplus. In that way, we compare the demand and supply numbers and look whether we are able to meet our country demand or we are export some of the agriculture commodities. Similarly, on fruits also and vegetables, here you look surplus. But once yesterday I taken account the post harvest losses, then only we find we are in. Here we are not taking into account the post harvest losses. Take 25% post harvest losses, then supply will be reduced by 25%, and this number will be. Similarly, milk under the consumption under 84 and the milk under 88. Food and we are in surplus of fisheries, fish, meat we are just sufficient or deficit little bit, and also they are little bit. Any question here? So this is the method and by the. So you have to read the now. If any question here, then before the papers. So it means you will learn 3 methods, and the last one is most commonly being used and gives the very good and simple. So let's go how to go the computation of this elasticity going with the supply model. Can you copy this? It is a supply model. Supply model. Yeah. Access. Okay. Okay. So we go this side. That's okay. Yeah, it's okay. Yeah, see? It will okay. Yeah. Go to first line. That's all. Yeah. Yes, yeah, that's all. Good. Yeah, this okay. So you are reading what was my dependent variable? Shares of human labor, shares of bullock labor, shares of machine. I think might be visible. Okay. Just we read the data. This instructions written in stata. Earlier, the instruction was limited, which is not that good. You write a instruction under the demand instruction also available in stata. That is it will be. So, see will explain. Now use the supply function. We have this supply data. What supply data we need? Input, use, and prices. So let's say we select select the crop number 16. We have the irrigation, real price of woman labor. The price of woman labor divided by price of crop. Bullock labor, machine labor, fertilizer, other inputs, and real price of other inputs, and value of other inputs, the seed, fertilizer, irrigation, pesticides, and so on. Then we count the share of human labor, share of bullock labor, share of machine labor, share of fertilizer, share of other. Means value of fertilizer divided by total cost. We get the then you work out. Okay. Similarly, okay. So these are my dependent values, right? And then I also use the value of main product. And these are the index of human labor, bullock labor price, machine labor price. Because value by main product, so they are giving reflection on price. Value of bullock, value of human labor divided by value of main product. So this is the human labor index, and so what we do, we impose the constraints of homogeneity. Sum of the coefficient is 0. Therefore, I am putting human labor equation, right? The first coefficient of human labor, second coefficient of human labor, third coefficient of human labor equal to 0. Similarly here, bullock labor equation, machine labor equation, fertilizer, human labor, and so on. Then here I am putting the cross price elasticity, that your symmetric conditions, that human labor, this coefficient of human labor and this coefficient of bullock labor must be equal. So that way we impose. Yeah, and then we estimate the shear regulation. We estimate all these equations, because here I define all variables, and then we estimate the shear estimates this equation, then second equation, third equation, fourth equation. So I am not estimating this equation, share of others, and share of others I derive from this parameter using the restrictions of additive conditions. That sum of this coefficient of all the equation must be equal to 1. If I subtract 1 minus all coefficients, that will determine the. Then I apply the constraints here. 1, 2, 3, 4, and these all constraints 1, 2, 3, 4, 9, 10, and then estimate it. Let's say something there, right? So this is the algorithm we write, and then we run the model under this step. Means here we get the data of inputs. Price multiplied by quantity, value of one input, value of second input, third input, and a thing. You have the total cost. You divide first input by total cost, you get the shares. Once you get the share, you regress that on the relative price of fertilizer, on labor, on everything, same way, and then impose the restrictions. And once you impose the restrictions, then you run the model, you get a beautiful estimated 6 equations, and 7th equation we derive by using the additive constraints. Means sum of all the coefficient of alpha equal to 1, equal to 0, so that we subtract and then make it 0. Whatever the residuals, that is the coefficient of the last equation. So that way, once you do on practice on hand on your laptop in the lab from tomorrow onwards, then so this is the base of this. Once you go to the practical classes for tomorrow, you read them first. Okay. So you will be quickly understand analysis. So now there are so many other papers. There are so many other papers. This paper is the demand for fish, right? Demand for fish in Asia, cross-country analysis, 6 country analysis were made. We estimated the demand for different inland fishes. And this is the profit function approach. Okay? And you can read that and see how we apply that, this model. Okay. So this is the one paper. Okay. Now we have demand model done, demand supply, and if you go here, demand supply analysis, this gives some handwritten notes, okay, for all the methods in demand and supply. Right. You also read, this will give the quick idea. If you want to spend less time, everything in this is the output supply equation, factor demand, and producer code system. This will help you to understand what is producer code system. Then you have the demand code system, consumer code system. Right? Once you go consumer code system, you just see market surplus model. And this is the paper I was referring, 1 January 1981. This is the core of the entire research on the demand supply analysis and so on. So first, if you want to try to understand, first read this paper. Once you read this paper, then only you understand how to drive all the formulas on income side, demand, and so on. Although we use formulas that time, which were not that good, but at least it gives the idea of methodology, how the things are being done. Here, this one. This is the first paper. Then you should read the sugarcane paper. Then you read the factor demand model. This here and income model. Go from here. Then you use the cost of production model. From there you can work demand for credit, demand for money, demand for capital, and so you can do that research. You can read the technical program measurement TFP, right? Now go that this is the TFP part. The TFP part, and then you go to demand analysis, and then you are going to hear the multi-state budgeting framework, right? If you don't have the time, read only this one paper. Actually, you get the gist of everything. It is a summary of my all 4 lectures. Okay. Now, this is the model, analytical model, expenditure model, first stage, second stage, third stage. Then you are estimating the food expenditure. In the slides, you may find some mistakes. Okay. So therefore, you read it. Sometimes beta gamma typing wrong in the slides. You read from it. So this is the second stage model. Now we go to the third stage model with all restrictions. This is the restriction, homogeneous restrictions, symmetric additive restrictions. Then go. Then you compute the elasticities from the demand model. You get the compensated elasticity, uncompensated elasticity. Go. Then you get the all elasticity, multiplied that. So you get the income elasticity of the subgroups. And if you know what is the probability of using that commodity, that theta you multiply, then you go for supply analysis here, profit function approach. Then profit function approach, use it. Then this is the price, relative price. This is the supply, supply. This is the factor demand, and then you get these coefficients. So, and this restriction, semi-definite, and so on. Right. So this paper summarize all the 4 lectures. Okay. So you read this, and then if you want to go further deeper, go supply code system. Okay, read the supply code system. This is the paper you read. Then you find all empirical results, how this translog model has been used. Go. This is the translog model, and then go. Then I apply this all conditions. Then I apply this shared equation we estimated, and we impose the restrictions. And from there, we derive the output price elasticity and factor demand elasticity. From the factor demand elasticity, we work out the this is factor demand elasticity. Using this, we use the price elasticity. So then this paper will give in detail about the estimation supply for number of crops. Here are the results. This is the supply projections. Then it explains what kind of data to be used and so on. So there, this is all your estimated human labor demand elasticity. These are the elasticity for different crops. Labor. Similarly, bullock labor, animal labor. Then you get the machine labor elasticity. You get the fertilizer demand elasticity. You get the irrigation elasticity. Then from there, after getting this, you get the supply elasticity. Machine labor, fertilizer demand, irrigation demand. Because then you can understand the writing and how we are interpreting those results. This is the predicted growth of input group, object group, then supply response elasticity. This is the supply response. And this is the input response. Yes, input is very inelastic. So even we know the subsidy, it's not going to affect the supply. But if you don't support the price support to the farmers, then supply will suffer. That is why the fixing price is very important. Guaranteed pricing. And farmers are demanding guaranteed price. Supply projections, we made it, number of commodities. Right? So this is the second. First, you read the first one, try to understand it a bit, then see the templates, and then read this paper. Then it will give easy understanding. Now, next paper. Which one? This is cost of cultivation. Then you go to demand code system. This one. Yeah. Estimation of demand elasticity. This is the estimation of demand elasticity for food commodities. And then we estimated 2 methods. Food characteristic demand system and the and quite small. Quite and food. So here also, if we read, it will give a better idea, and we compare these two elasticities because we already rejected all the models based on calorie income elasticities, and therefore these two models are used for estimating the linear and you just read the review. Limitations of each model we try to explain in very brief. That will give you better idea. And then if you classify the household in different groups, you can how you can classify the household poverty line, above the poverty line, below the poverty line. Again, you can classify that non-poor, I 25% above the poverty line, 25% below the poverty line. You can make 3 income groups, 4 income groups. That also is possible because we say poor. Who is poor? Right? They are the non-poor. They are the non-poor low, non-poor high, moderate, and very high. So that way you can classify using the poverty line as a baseline. So that we try to explain the Coates model. We try to see the limitation. Then we say this is budgetary framework, Coates model, and these are the constraints. These are the conditions we used. Okay. Why it was true? Because we are using this. If you substitute this over here, you find this a quadratic log n y square. And once you differentiate, you find 2. That is very now quadratic Gates model is coming. Then you have this all elasticities formula, you estimate, you have compensated and compensated, and so this will give the fairly good knowledge of estimation of about demand elasticities, the supply model will give the supply elasticities, and then use it to play data and practice. As much as you practice, you'll be able to build the confidence. And once you build the confidence, then you find it is a child play game. It does not take much time. Right? Yeah, once you, and then in the template, we have developed very systematically how to get the elasticity. Otherwise, using the right way, computing elasticity from the estimate parameters is a difficult task. Then in the demand side, we estimate the M matrix on the coefficient. Then we take the advantage of SPSS, the data. Then there we apply the formula, and then only we report the number. You may write the program in Stata also, same thing. Maybe in one stop you can get it. But I was not able to do that time. Now it is a food characteristic demand system, which I say utility is a function of energy, variety, quantities, and non-food items. And then we develop the SM matrix out of this. Yeah. So from there, we estimated this all. So for this, you have one policy paper 98 IRI, demand supply projections. Here you find a more details about the estimations, and then here also you get it. A food basket and nutrition level. Based on that, we apply this agenda. That these are the calories. This is the money coefficients, and so I forgot many. So that way you will compute so beautifully all elasticities and conventional shares. So this all about that demand, supply, and shortness. So this will not make you perfect. You take it very carefully and spend a lot of time on it. But keep in mind, nothing is very difficult. They are, if you practice, they become very, very simple. And you will be excited to do more work. And then if you read the all policy paper before that, you find how you can integrate that the coefficient for policy analysis. You raise a question in your mind and try to answer those questions. Anything you have a question. Suppose someone asks, I want to increase the supply of rise by 5%. How I can do it? What are the probable options with me? Then one can say increase the price of rice, double, so farmers will grow more and the question comes, if I grow double price, what about consumer? Consumer cannot afford. If consumer cannot afford, government has to give more delay and compensate cost, consumer cost, and from where the money will come. So that way, question comes. You have number of options, solutions. Okay, I'll try to increase not the price, but I like to improve the technology, knowledge base, so that the cost is low. So you can select number of answers and then examine and evaluate which is the most feasible and which can take forward without adding additional cost to the public sector on the government, neither on consumer, and it is friendly to all in terms of nutrition and food security. That way, one has to think, raise the question, try to answer that, and examine that how it works. So that's it. So now, so I have been told that there will be number of questions, so we'll come on that side. So I think there is enough time, half an hour we can spend. Any question so far on this? So you promise you read all papers. You start with the simplest one, then go for the demand and supply paper, TFP paper, right? And then come prepare for the training of 2 weeks with survey, and then only you feel comfortable. And so within 2 weeks you feel very comfortable by reading all information, assumptions, and then read the demand supply projection policy paper 98 to understand how to estimate indirect demand, how to estimate demand for seed, feed, wastage, and so on. Right? That will give very good knowledge. Okay. So until you read, I'm sure that the literature which I gave is good enough to understand this difficult process in simple way. Now let's have a question from those who are attending from did you receive some questions?
Sir, in projection, the power T each time period. In projection equation last you have told, when we are writing the projection.
I classify the household based on poverty line. Household distribution.
Yeah, it's okay, sir. For projection equation, actually. Power T means here the time period.
T is a technology, in fact.
Technology.
Yeah.
But how to consider? Can you go study for the projection equation where it's demand or supply water? Just
Supply.
many equation is the last literature.
Yeah, it is a T, TFP. Okay, I think something there. Yeah. No, this is okay. Yeah. Whatever the T I mentioned technology. Technology means TFT. Total factor productivity.
Sir, suppose this is the supply projection.
Oh, T is the time.
Yeah.
It's like you deposit your FD in the bank,
Okay.
money bank, and you say I will give you 5% interest. So what you say? 1 plus 5 by 100 You say, I want to keep the money for 3 years. The T is
So
3.
that is means for how many years we are doing the projections?
That's right.
That year.
That's right. And if you don't want to put T here, then you write ST minus 1. We use say supply, that add to growth. This T is in that. Capital T is T.
Capital T
Is a time period. Okay. Now, there is another paper on the. I saw you. Then EPW paper also you can read and see how we can measure the climate effect on demand, supply, and prices. There is a paper on subsidy versus technology. There you find how we are able to predict the prices. I think I can show you some. That paper, there are 2 more papers. Yeah. You have some paper? Yeah. Yeah. If you come here, that this is a paper where we like to see the impact of climate change. What is the effect of climate change on supply? Because climate affects the supply, and supply affects the price. Price affects the demand, and so you read this paper. Go, and here we start very simple model. Your supply model. Supply is a function of area, yield, ERP, and climate factors.
in climatic factors.
Yeah. Yeah. Then we say area acreage model. How the acreage influenced by the last year acreage, then rainfall in the month at the time of sowing.
Sowing that.
Right? We write down. Then I take yield model. Yield model, the last year yield, this year yield, the rainfall during the growth period. Because sowing period growth will affect the acreage, and the productivity will be affected at the time of growth of the crop, flowering of the crop, the seed settling of the crop.
So suppose for growth 2 months are taken by the crop. So we have taken the
Yeah,
rainfall for 2
yeah,
months.
2-3 months. Yeah, here, month, then month, another. Which month we feel more critical for the growth? Then we write the yield model. Go for that, and then you compute. We find out these coefficients from there, and this will give the long-term elasticity. Just like in our model, you might be B divided by 1 minus S lambda. Okay. So we write the total demand model. This is the demand model, and then we write the price model, supply model. We write
Sir, we
demand
have
model.
to estimate the growth by this question.
Which growth? This
Total
growth,
demand
this supply
growth.
growth. No,
Supply growth.
you need this elasticity.
For supply growth, we need the elasticity.
For everything, you need elasticity.
Yeah, but for growth, this growth, how we can
Oh, growth, I will explain more also. Your growth is equal to elasticity, growth of price, growth of the input price effect on supply.
I get it, sir, but how to estimate the growth? Growth means
No. This price, you have times this data on price. Take the growth.
simple growth, na sir? Yeah, CGR
Yeah, log y is equal to alpha plus
compound
beta.
annual growth rate.
That's right. Same way you come everything, right? And then only you go to demand model. Okay. Your demand is per capita demand, then price. Then you get the indirect demand, how the indirect demands are there. So you can build that thing into model itself. Indirect
When
demand.
we build as a total demand model, then we have to plus direct plus indirect demand.
Yeah, direct
At
indirect
last.
demand, and if you put in growth form, beautifully it comes. Shares.
This total as a whole.
That's right. And then you go, then equate these two. You get the price model. Your price is the effect of input price, EFP, drop effect, and demand sisters. So that is your price model. Here you can predict the prices, price forecasting. You can do from here. So we know if the climate factor, if there is a drop 30%, then what will be its effect on prices? What will it effect on demand, supply? How much government should procure from other places? How they should regionally distribute it? If one region is dropped, another region is not dropped. So that's why
When
the,
climate factors are only rainfall is sufficient, other than rainfall also.
yes, and you have to extend this. Temperature is also important, but mostly major
So
is
for growth and
always
all
in
these
forecasting.
temperature and
We always say
humidity.
monsoon is normal. So government says, okay, we are going to get a bumper rate. Monsoon is abnormal, share market drop, right? So as soon as so rainfall is the most important in our conditions because more than 50% land is unirrigated. You go from here. So that's why you can have the effect of April month, April, June, July, August. We have to identify the month which are most important and how to use it. Rainfall deviation from the normal rainfall. We take the deviation from normal rainfall and that value we use it. Yeah. And then we have the price growth model. Okay. So here you can know what is the effect of population. If population increase fast, what will be the effect on price? What is the effect of product price? What is the effect of PFP? What is the effect on activity? What is the effect on demand and income and so? Then you can form ISO points of 2 variables, 3 variables, and work out the policies. That if I do this, I'll get this. If I do this, then I'll get different. Someone say, stabilize the price. Then start thinking about this line. How I can stabilize the price? Shall I reduce the population? Shall I shift the seed wastage? Shall I reduce or increase the demand? Or shall I work on PFP? If you work PFP, then again comes how much I should invest on irrigation, how much I should invest on extension, how much to spend on research, how many universities, how many projects I should bring. So that kind of policy dimension comes. Now what? So this is very important for students to take up their PhDs looking under this framework. Right? Now, yield response, climatic variable change. Then here we try to estimate yield response to price, yield response to factor. Here we projected that if 10% deficit, this is the demand supply. If 20%, this is demand supply and prices. Now go up. I think many of you have missed this paper for reading it today. Anyway, I told you, my all 40 years research I put in this is 2 papers, this paper and that one. So this all. Right? So you, whatever you are learning, demand, supply, price, everything is there. Sources of supply. Here this is important. What are the sources? How we can manipulate? Price model for commodities. Right? You always think about forecasting prices. I think some project is coming where you want to forecast. That will make use of it. Once all, since now you have all kind of elasticities, then this work will become much simpler. Because the service work is not merely projections. Most important part is estimation of elasticities. And those elasticities can be used now to take up the further studies and read. Once you read it, it will click that how I can use it. And you can add, you can use your wisdom. Right? Along with that. Yeah. So my wisdom was very effect of drop on crop economy. Right? That's very important. Then effect of growth on crop economy you are studying. Then you go up Then you have the sources of growth on this. Impact of growth on supply and demand. Right? So, yeah. And so we might be having full report also, where you find all detailed. But I think most of the part is there. So once we are submitting before the journal will say cut so, but they publish as such. Not a single word has changed. No. Okay? I think you'll enjoy it once you read it. With another paper, impact, technology versus this one. Okay. This paper also in here, this input subsidy versus. Here also, Joshi and myself, we work on this. Joshi came here, no?
Online.
Online.
Is it
Online. अच्छा, ये same thing you are finding producer code system, which I explained. You have the accurate response model. This way. You have the TFP response model. Then you integrate all of them. Then you get the supply growth model. Then you have the income model. So far, you do not have the income model. Only in the market surplus, generally at market paper also, you are finding the income model. And this income model of this is also you will find this model. Yeah. So, wow. And then this is the formula. Okay. You want to study the effect of price on income. This is the elasticity, factor demand, factor supply elasticities. And this is this all. So once you know this elasticities, and they are the averages of quantities, you can compute that. And so these are all formulas. They are coming in that paper, 81 paper, 1981 January tomorrow. And then code system. You try to understand. If you write one to other, how to integrate, and you can add up only if you have the growth models. And growth I have shown in one name that any equation you can write in growth, and that adding and merging become too easy. So you get this. So this way you keep running and see. You read this paper also. So once you read these all papers, I'm sure you will not have any problem of choosing your research topics and using good techniques and drawing the policy conclusions out of it. Right? But once you have to read, you have to devote time. Don't be afraid about alpha beta. Okay? They are too simple. Once you understand the abbreviation, you can. So I don't have what I have. My knowledge I have already given and done on. Nothing left.
IMR की calculation, IMR.
That you do by Tobit model. वो दिया वो template देखिए. The template you need, you find.
Excel sheet में
Excel में
नहीं उसमें लिखा था ना टॉपिक
उसमें है ना टेम्पलेट जो आपका डिमांड का टेम्पलेट I shown upper part and bottom part in middle of that. Or just write IMR in Google now will state also work out. What we do, we just take a topic whether using or not using, okay? That probability will be there. And then once you ask how to compute by calculator, that I don't know. Only software is there, and they provide the file, and which you can store and save and use as a data. But many times, sometimes the model gets converted. For pulses I use it. Some for 2-3 pulses it will not convert. And you are helpless. Keep running. Yeah, everything is not that simple, but whatever good thing comes. So now it is your turn. Now I know very difficult to ask any question, but you may have something in mind or something related to your thesis, related to your work you are doing. How I can help you using this wisdom. That's the. Don't ask the question on my presentation. You ask the question, what things are bothering you for your research?
Anyone have?
Sometimes the variety doesn't change there on
Self projection, it may fluctuating like anything. Just right now, then you can say the northern India, there is Basmati.
No, that is why we compose the TFP, total cycle cost. We compose. Because the technology is changing over here. So, because once technology is there, it start giving the results. After some time, the appreciation of technology takes place. Another research comes and take the boost from that. So that is why the concept of TFP. For each crop, we should work TFP. We should work by variety wise and then try to mitigate. So through TFP, we can handle that. What will be the impact of change on contribution of varieties of
Because there are so many people basing on the beating cotton. Like when we are thinking for other crops, that is only limiting. But technologies are
no,
there.
the cotton work is okay. You are doing the production function and one local varieties and hybrid varieties and then decompose it and working the technology effect, working the addition use of the effect. Those works we did in 1980. Sometimes this is by then consumer sector support also. But TFP means we want to measure the changes in technology over time. What is TFP does? It
But
measures
sir, how
the
we consider the time period? Because suppose you are using the NSSO data, so different
No,
terms
no.
data we are.
for TFP we
No,
don't use.
not TFT, it's for projections. But in projections and in consumption pattern, we are using the TFT. So
No,
how we
in
consider
conjunction pattern. No, TFP we are using from supply side.
supply side, yeah.
And then demand and supply we are merging
Hmm.
to get the price forecast. So once you integrate these two demand supply and trade, then only that price part comes.
For supply side, we are having the cost of production.
So demand side only the demand. Supply side, then we have technology, we have trade. That I showed that chart fully that how you have the producer code system, consumer code system, and trademark. So this three has to combine. And that works.
Someone want to work on solar pump or a solar panel, the consumption and everything. That is come under the TF.
No, solar panel work is different. And
Because it is also, we can say in agriculture, there are technology.
yeah, that is definitely. That's why I say you have irrigation, whether you have flood irrigation, or whether you have drip irrigation, whether you have stream irrigation. That is technology. Now you say energy, whether you have solar energy, wind energy, electric energy, coal energy, and which way it goes. So you have to think on those. I'm not so well.
Because there are some
Yeah. Idea of literature, really. So then you can apply your mind in other direction efficiently. That is the purpose of doing all this.
because one of the students is doing, but I'm only making comparison. Non and
Yeah. That you have to make in terms of cost,
in terms of profit.
cost, cost of business, and so and efficiency. That which electricity more efficient. Whether the solar energy or wind energy or coal energy. For coal energy, you have to depend on the supply of that. But when you are not getting, just like we have canal water and well water. We say well water is more efficient than canal water. So that way you have to apply and think. So anyway, it's my pleasure to be here and see you are reading my papers, other things, but physically you are seeing me now.
Yes. We have heard so many times from this in this, sir, it's so.
And you might be thinking I'm a very old person or
No, sir.
77 years old. Right? So, person never get old. Keep working. Okay. I think we will give you both tea and okay, thank you very much. All papers to everyone, and then literature is something there you will write. My mail, email is there. Otherwise, very simple mail, P. Kumar IAR. P. Kumar, my name, IRI, my institution, at the date of the so you can always remember my name P. Kumar, if you remember IARI, P. Kumar IARI, at the date of the
Thank you so much, sir. It's our pleasure to learn so many things from you. Now I would like to invite our CCPI of Nahidkas project, Dr. Lal sir, for a vote of thanks and for the conclusion of this.
Good afternoon, everybody. I think your clapping is already tell what I have to do fast and fast. As a part of the customary, thank you so much, sir, for presenting over here. From you can say in 2 days, I think so many times you are telling in this theory that demand and supply projection is an everything. But when we see in a practical way, that is a totally change. Even we can say that our some of the colleagues also we are working in the past about the demand, supply, and everything. But when we see the Excel sheet, then after we are realized that is the key portion when you have to drive it and you can get it. But if you work hard, you can get the precious thing from the same ocean. So sir has, I think in the last 2 days, sir has got so many topics. We can say the total factor TFT. Even TFT, we are thinking for so many times. The government is asking about what is the impact of university, or what university actually in last 20 years. We have a technology. What is this cost behind it? What is this buyback and everything? Calculate. But when you are seeing your presentations, in the future we can give something to the government also, so they can think before questioning your university. Thank you so much, sir, for your covering all the topics which we are you are agreed on, and I think in the next 2 or 3 years you can get the good pieces working on the TFT. Thank you so much.